Identifying and representing functions. Function, an input-output relationship that has exactly one output for each input. Input is the value substituted into an expression or function. Output, the value that results from the substitution of a given input into an expression or function. Typically, when you're looking at input-output tables, the input is typically the X and the output is the Y. All right. Okay, so if we look at the relationship of this function, they're saying that they want to know, is this a function or not a function? The input is our X. Let me change the color here. And the output is the Y. Alright, so I have the input 1, 3, and 7. And 1 comes out with 2, 3 comes out with 8, 7 comes out with 6. This is a function. And the reason why this is a function is that each input is paired with only one output. Each input is paired with only one output. Okay? Now, in this case here, we have 0 is paired with 1 and 2 is paired with 4 and 5. This is not a function. If you see here, the input has two different outputs, which makes it not a function. It has more than one output value. All right, let's go to number 4. Determine whether each relationship is a function. So we have 7 goes with 3, 8 goes with 1, 9 goes with 1, and 10 goes with 2. This is a function. So each input has only one output. Each input has only one output. All right, number 5. 3 goes with 0, 2, 4, and 6. This is not a function. Because the input has more than one output. So it has more than one output. The input has more than one output. Okay, now I want you to be aware that even though it's written like this in a mapping diagram, you could also see A, B, 4, and 5 in either a table like format, like this, or you could see it in ordered pair format like this. Okay, which we're going to talk about next. So just realize that this mapping is the same thing as a table and ordered pairs. Alright, so identifying functions from table, example 2. We have 5 is paired with 7, 10 is with 6, 15 is with 15, 20 with 2, and 25 with 15. Okay, so right here, this is going to be a function. So the reason why this is a function is each input has only one output. Not one of these x's were repeated. They were 5, 10, 15, 20. So here it is. Each input value is paired with only one output. Okay, let's go to example B. We have 1 with 10, 5 with 8, 4 with 6, 1 with 4, and 7 with 2. Right here is a problem because we have the x repeated. So this is not a function. And the reason it is not a function, we have the input value is paired with more than one output. All right, let's look at number 7. We have 53 paired with 53, 24 with 24, 32 with 32, 17 with 17, 45 with 45. This is a function. Our reasoning is each input has only one output. Alright, let's look at number 8. 14 with 52, 8 with 21, 27 with 16, 36 with 25, 8 with 34. Right here, I have 8 and 21 and 8 and 34. This is not a function. Okay, remembering our reasoning, the input 8 has more than one output. Alright, the last thing that we're going to take a look at is tables. So, identifying functions from graphs. The graph shows the relationship between the number of hours students spent studying for an exam and the exam grades. Is this relationship represented by the graph a function? Alright, so we have 170, 270, 285, 375, 580, 682, 788, 990, 995, 1298. Right here, you have 270 and 285. That is not a function. In addition to that, you have 990 and 995. So this is not a function. Okay, remember it's not a function because the input has more than one output. There's also something called the straight line test that can help us here. If we have, let's say, a straight line, and we take and we pass it through this line right here, it's going to go through 2 points, so it's not a function. This is 1 point, 1 point, 1 point, 1 point. This passes through 2 points. This is only 1 point. So right here and here, it does not pass the straight line test. Okay, let's go to number 10. The graph shows the relationship between the heights and weights of the members of the basketball team. Is this relationship represented by the graph a function? Alright, so we can do the straight line test again. This is just 1 point, no points. Oh, there are 2 points right here at 70, so that's not going to help. And at 71, there's 2 things here, and here's just 1. So based upon the straight line test, this is not a function. Okay, the reason why it's not a function is because you have the ordered pair 70 and we'll say 165, and then it's also 70 and 175. So the input has more than one output. Also, we have the ordered pair 71 is with 170 and 71 is with 185. This is not a function.